Hello, my name is Igor Pinto. So I'm going to show you how I did the analysis for datasheet number 5 and datasheet number 6. So for datasheet number 5, first I did a full factorial design uh, with 3 factors, 1 replicate, and 24 runs. So the type of design that I chose for this datasheet and for the factorial design, it was full factorial design. This because two of the level of the factors have more than two levels. It's 3 and 4 levels. So for sites, the number of levels is 3. For irrigation, it's 2. And for fertilizer, the number of levels is 4. So then I did the analysis of the factorial design. We can see here that F value and P value, as well as the model summary, show just asterisks, no values in it. So I decided to take out of the analysis the three-way interaction sites, irrigation, fertilizer. So I did the analysis again after it. So now we can see that there's value on F value and P value. And based on this ANOVA and on the p-value, we can take the decision of which factors are significant or not here, because if the p-value is less than the level of significance 0.05, this is an indicator that this factor is significant. So the ones that are less than the level of significance here are factor irrigation and fertilizer only. So here we have the model summary. We see an R square of 96.12% and an R square adjusted of 85.12%. So this is an acceptable value, but we could improve it by making some adjustment on the model. Here we can see the coefficients and the regression equation, which is made out of these coefficients. We can see that there are two unusual observations, observation number 4 and observation number 8. So we cannot take these observations out of the model because that would be kind of like cheating on the model, because these unusual observations are mostly due to an error in the experiment. So what I would do to manage these unusual observations is just to write it down on the report, so the people that made the experiment can take a look on these observations and maybe check their equipment or their technique on taking this on making the experiment. So here on the Pareto chart, we can see as well that the factors that seems to be significant due to the standardized effect are C and B. On the normal probability plot, we can see that it's kind of like S-shaped and has some outliers on the beginning and at the end. The versus fit shows some kind of dependence on the fitted values and the residuals. So what I did was to take out the B and C interaction, and I made the analysis again. So here's the ANOVA. So by doing this, I got a better R square and R square adjusted values. So the Pareto chart still showing C and B are the significant factors. The normal probability plot still kind of like S-shaped and with some outliers. And the versus fit still showing some kind of fun shape. So I made the analysis again. I took out the A and B fact interaction. And after doing that, I got an even better R square adjusted and an R square on the model summary. This is an indication that we're going to the right path, because an R square adjusted, a higher square R square adjusted is an indication that of a better model. So still showing here two unusual observations. The Pareto chart still showing that C and B are significant factors. Normal probability plot, we can see here that it has improved a lot. It's more like linear shape on the dots, no outliers, and the versus fit, it's kind of randomized, but let's see if we can improve it even more by taking out the A factor. So to do this, I had to choose the non-hierarchical model because we're taking one of the main factors out. So after doing this, we can see that the R square and R square adjusted have a higher value than on the past analysis. So this is an indication that we're improving the model. Now it only shows that there is one unusual observation, which is also an indication that we are improving the model. And the Pareto chart still showing C and B as significant factors. Normal probability plot, it shows straight line, which indicates normal distribution. Versus fit, we can see here that still it is now completely randomized, no pattern, so we know that it is correct. So finally, what I did is to take out the AC interaction factor to see if this would improve the model. But after doing that, I noticed that the R square adjusted it's lower than if we kept the A and C interaction. Also, the normal probability plot went back to an S shape, and we can see some spaces in between here and the versus fit, which indicates that the model is now not correct. So this is the best model for the analysis to keep the ANC factor. So after that, I did the factorial plots for yield. So here we have the main effect plots for yield, for irrigation and fertilizer. And finally, what I did is the power analysis. So what I did here for the power analysis, it's to input a maximum difference of the means. I used these effects plots. So I did the subtraction between the maximum and the minimum mean of irrigation and fertilizer, and got a value of 146.742. One replicate, 24 runs, and the standard deviation, I got it by taking here on the ANOVA, the adjusted mean square of the error. I did the square root of that and got standard deviation of 31.453. So I got a power this analysis of 1. So now for datasheet number 6, I did the same. I made a full factorial design, but now it's 5 factors and 48 runs, still 1 replicate, and the number of levels, it's 2 for A, B, C, and D, and 3 for E. So then I did the analysis. As well as on the datasheet number 5, we can see that F value and P value, there's no any number for it, just asterisk, as well as on the model summary. So first, I decided to take out the 5-way interaction. After doing that, I did the analysis again. Now we can see there are values on F value and P value. And we can see that we have an R square of 97.71%, and 46.14%. Here are the coefficients as well as the regression equation made out of the coefficients. Here we have the Pareto chart and the normal probability plot, which is totally has a weird shape that does not indicate at all that it is following a normal distribution. Versus fit, still it's not randomized enough. We can see two spaces in between here. And so what I did is take out the A factor and make the analysis again. So after doing this, I got a better R-square adjusted value than on the past analysis. We can see here. And normal probability plot still has an S shape. So what I did is to take out the factor B to see if we can keep improving the model. So after taking out of the analysis factor B, we can see that the model it's improving because we have an R square of R square adjusted of 71.90% and an R square of 97.61%. So the Pareto chart, we can see that it's showing now some of the factors that and interactions that are significant. Unfortunately, the normal probability plot still kind of like S-shaped, versus fit still showing here some patterns. So what I did next is to take out the C and D factor interaction. Also, on this analysis, we don't see that there are any unusual observations. So I did the analysis again. So after taking out C and D interaction, we can see that the R square and R square adjusted are higher than on the past analysis. We got an R square of 76.07% and an R square of 97.45%. So this means that by taking out this interaction, we are improving the model. Also, here we have the Pareto chart still showing which are the significant effects, as well as here on the ANOVA. We can see from the p-values, we can see which are the significant effects. So no unusual observations. Normal probability plot still has some outliers here at the end and at the beginning, but it's kind of like taking more like a linear pattern that the one that was kind of like an S versus fit. We can still here see some patterns. So I did the analysis again, now taking factors B and C. After doing this, we had an R square of 78.09%, which still means that we're improving the model. So we got an R square of 97.20% and R square adjusted of 78.09%. Here we have the Pareto plot and normal probability plot. We can still see that it's improving, but we can improve it a little more, maybe by taking out the B, C, and D factor, which is what I did next. So by doing this, I did the analysis again, and we had an R square of 96.82% and an R square adjusted value of 78.62%, which means that still we're improving the model. So from the normal probability plot, we can now see that it follows a linear, that it has a linear shape, and the versus fit, we can see that it is now randomized. It doesn't follow any patterns, so we can say that it is correct. Anyway, I kept taking out these factors that, according to the Pareto chart and the ANOVA, are not significant. But after doing this, the R square adjusted value just kept getting lower and lower. We can see here, lower value, even lower. So the conclusion was that taking out more interactions or factors will not improve anymore the model. So I stopped here. The best R square and R square adjusted that we could get was 78.62% and 96.82%. So this is the most improved model that I could get by adjusting it. We can see here the normal probability plot and the versus fit, all correct. So finally, I did the power and sample, the power analysis for datasheet number 6. Well, first I did the main effects plot and the interaction plot for performance. And then I did the power analysis for datasheet number 6. I did the maximum difference between the mean of the factors, which was 5.3177, and one replication, 48 runs. The standard deviation as well, I got it from the analysis of the general of the factorial design. The adjusted mean square, the error from the error, the square root of that. So I got the standard deviation of 3.5958 and got a power for this analysis of 0.95, which is an accepted power. I would say pretty good, as well as on the datasheet number 5. So that's the analysis I did for both of these data sheets. And that's it. Thank you very much.